So yeah, let's get started, guys. Without any further ado, we'll briefly talk about networking fundamentals. As mentioned, this is also a demo session for you to understand how the classes are being taken. And again, if you're interested, you can register after the demos are done. So the demos will only last until this Thursday, guys. So again, from Monday, the link is going to change. So if you're interested, after you've been through the earlier classes, if you feel that this is a good enough course for you, please register at the earliest. So yeah, let's get started without any further ado. When you talk about networking, there are three important definitions to know. What is networking, what are networks, and what are hosts. So networking is the concept, or it is the practice of connecting information devices. Now, these information devices can be anything. They can be as small as a mobile phone to as big as a web application server or a database. Okay, so the practice of connecting all these information systems with one another so that they can share resources or information is called as network. And when you have a collection of those devices connected with each other, those interconnected devices, they collectively are called as a network. So a network is a collection of interconnected devices. Again, as mentioned, examples like computers, servers, printers, whatever it be, so that they can communicate with each other. And each of those devices in that network is called as a host. So host refers to any system or any information device connected to a network that can transmit or receive data, which means it can send or receive data from other devices. As mentioned, examples, your computers, printers, routers, mobile phones, again, security cameras, databases, web servers, whatever it be. All of these devices individually are called as hosts. Okay. Now, just like how we humans have names to communicate with each other or address each other, these devices or information systems also have names. Okay. And that name is called as an IP address, Internet Protocol Address. This was developed by the US military in the early 1950s or so. Okay, and again, there were various versions of it, experimental versions, IPv1, IPv2, IPv3, version 1, version 2, version 3. They were experimental, they didn't work out successfully. What properly worked out or got implemented later on was IP version 4. In short, again, that is abbreviated as Internet Protocol version 4. Okay, now this IPv4 address has a few properties to it. So let's talk about that. So again, as mentioned, each host on the network has a unique identifier, a unique name that is called as an IP address. And these IP addresses allow devices to communicate or transmit data among themselves. So firstly, this IPv4 address is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros and ones consecutively. So if it is the smallest data structure or a data format in computers, it is either equal to the value of 0 or the value of 1. And your devices, your information devices like computers, communicate with each other in the language of zeros and ones. And this language is also commonly known as the binary language. Binary in the sense only two digits, either 0 or 1. Okay, so 0 is like low frequency, 1 is like high frequency. And with that sequence of zeros and ones, computers communicate with one another. And your IPv4 address is a sequence of 32 zeros and ones or 32 bits. Okay. And this 32-bit address is again equally divided in 4 parts. Okay. And each part of 8 bits is called as an octet. So here's one octet. This is the second one, third one, and fourth one. And each octet is separated by a dot symbol. So if you count this up, this would be 32 zeros and ones. Okay. And this 32-bit address is divided in 4 equal parts of each 8-bit portion. Okay. And that each portion is called as an octet. It's an important point to note. Now, this number that you see here is in the language of zeros and ones, also called as a binary language. Computers easily understand binary, but we humans don't. What we humans regularly use or understand are decimal numbers, numbers from 0 to 9. Yeah. So now I'll show you how to convert any binary number to a human readable decimal number. So this number 11000000 is actually equivalent to 192. Okay, so I'll show you how this number got converted to 192. 10101000 is actually equal to 168. All zeros is equal to 0, and 00001010 is equal to 10. So let's learn how this conversion happens. Okay. Before that, any questions or doubts up to this point? Anyone? Kiran, Vishwanath, Suraya, Jabin, Himanshu, Pradhan.
From my end,
Okay, assuming there are no questions, let's proceed to the next slide. As mentioned, What shall I explain, Vishwanath? Once again, which part? Hello? Oh, yeah, again, as mentioned, when you talk about IPv4 address, it stands for Internet Protocol version 4 address. This was developed by the US military, and this has 32 bits in it. 32 bits in the sense 32 zeros and ones. Okay. This 32-bit address, these 32 zeros and ones are divided in 4 equal parts, where each 8-bit portion is called as an octet, and each octet is separated by a dot symbol. That's a simple explanation of what IPv4 is. Okay. So this is the syntax of any IPv4 address that you have. But what you see here is a binary number, a number in zeros and ones. We humans might not easily understand that. So now we'll learn how do you convert that binary number to a human readable decimal number. Decimal numbers in the sense numbers from 0 to 9. Okay. Is that clear? Vishwanath?
Yes, sir.
Right. Progressing forward. Now let's talk about the conversion. So again, to convert any binary number to a decimal number, there are two simple routes. So let's take the example of this number 10101010. When you have to convert this number, this binary number, 8-bit portion number, into a decimal number, rule number one is you write down all the values from 2 power 0 all the way up to 2 power 7 from right to left. So under the rightmost bit, you have 2 power 0, then you have 2 power 1, then you have 2 power 2, then you have 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. So from right to left, you write down the values of 2 power 0 to 2 power 7. Now, if you have a question why specifically 2 power, again, this is a binary number. You only have two possibilities. Hence, that is why you're putting the value 2 power everywhere. Okay. Once these values are written down, all you have to do now to calculate or get the final decimal number is you multiply the lower number with the top one and keep on adding it with till the next one or to the last one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So in order to perform this multiplication and calculation, you need to know the values of these numbers. So anything to the power 0 is always equal to 1. So 2 power 0 is 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 similarly, 32. 2 power 6 is 64, and 2 power 7 is 128. Now, once you know these values, you just multiply the lower number with the top one and add it up. So 2 power 0 into 0. So 2 power 0 is 1. 1 into 0, that's 0 itself. Okay. 2 power 1 into 1, 2 power 1 is 2. 2 into 1, 2. 2 power 2 into 0, 0. 2 power 3 into 1 is 8. 2 power 4 into 0, 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, 128. Now when we add all this up, 128 plus 32 plus 8 plus 2, you get the final number as 170. So when we humans read the number as 170, the computer reads it as 10101010, something like high frequency, low frequency, high, low, high, low, high, low. Okay. So when that sequence of frequency travels, the computer understands the number as 170. Okay. Is that clear? Everyone? Kiran, Vishwanath, Suraya, Himanshu. Again, this is very important to understand, guys, because from this itself, we'll understand the range of IP addresses. So any questions up to this point? Anyone?
Sir, excuse me.
Yeah, Kiran.
Actually, I'm confusing on this. Actually, for
Mhm.
to how to read these like from left to right or right to
From
left?
right to left, from right to the rightmost bit will have 2 power 0. And as you progress to the left, you'll have increasing numbers. Rightmost will have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3. And on the leftmost, you'll have 2 power 7. And you simply multiply the lower number with the top one and keep on adding till the last number. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. I've written down all the values for 2 power 0 up to 2 power 7 on the right side, if you notice. 2 power 0 is 1. So 1 into 0 is 0 itself. 2 power 1 into 1, 2. 2 power 2 into 0, 0. 2 power 3 into 1, 8. 2 power 4 into 0, 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, 128. Okay, if you add all them up, you get the number 170. Is that clear? Kiran?
Yes.
Right. Himanshu, Suraya, Vishwanath, any questions? Does anyone want me to explain it again? Please do not hesitate, guys. If you don't understand, please do let me know. I can explain it as many times as you want, because as mentioned, this is very important for the upcoming topic, okay, for what I'm going to explain next. So anyone who has any questions, please do let me know. I can explain it again if you don't understand. Okay, assuming everyone has understood this concept, guys, if you have understood this, I have two more numbers here. I have number 0, 1, 0, 1, 0, 1, 0, 1, and I have a number all ones. So using the same logic, I want you to calculate the decimal answers for this and give me the value. So again, 0, 1, 0, 1, 0, 1, 0, 1, and all ones. So I've written down the values here from again on the bottom as well. All you have to do is calculate and give me the final answer. And all the values from 2 power 0 to 2 power 7 are mentioned here. So you can look at this table, you can calculate and give me the final answer. Please take your time, no rush, don't make any mathematical errors. Calculate and give me the final answer for both the numbers. Okay, if you have a pen and a paper beside you, please calculate and give me the answer.
254.
254 for which number?
255 total.
For which number? For the top one or the bottom one?
Bottom. Second. Oh, you are asking first one.
Five, bottom one. Okay, what about the top one? 0, 1,
Top
0, 1, 0, 1, 0, 1. Okay, Himanshu has given me an answer for the top one as well. Okay, we'll check that out, Himanshu, in a minute. Let's wait for the others as well. Any answers for the top number, guys?
First one is 86.
86. Okay, we'll check this out. Okay, guys, let's try calculating them now since I've got a couple answers. So 2 power, again, as mentioned, you write down the values from 2 power 0 all the way up to 2 power 7 from right to left. Okay, so 2 power 0 into 1. 2 power 0 is 1. 1 into 1, that's 1. 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. 2 power 7 into 0, 0. Now, if we add all this up, 64 plus 16, that is 80. 80 plus 4, 84. 84 plus 1, 85. So the first number, the correct answer for the first one is 85. Very close, Kiran, but again, good attempt. Himanshu, your answer was right. Okay. Secondly, when you put all ones, you just add all these numbers up. Okay, so 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you add all that up, you get 255. Okay. Oh, just a second, guys. I'm so sorry. Someone's at the door. Let me quickly get that. Sorry for the interruption. Right, I'm back. So, Kiran, I hope you understood where the error was. I guess you got one extra number. I can't. Yeah, perfect. Right. Now, the reason I'm explaining all this conversion, guys, is again, no one would ask you this in real time, but you would now logically know what's the first IP and what's the last IP. So if I had to get the first IP, all I have to do is simply put zeros everywhere. So in all the octets, I have 0, 0, 0, 0, 0, 0, 8 zeros here, 8 zeros here, 8 zeros here, 8 zeros here. And when we convert that from binary to decimal, first IP is 0 dot 0 dot 0 dot 0. And if I had to get the last IP, I simply put the maximum value, all ones. And when we put all ones, you get the number 255, 255, 255, 255. Here's the first IP, and here is the last IP. So you would never have IP addresses in the negative numbers or in the numbers above the value 255. That is never possible. Reason being, when you put all ones, the maximum number it can go up to is in decimals, 255, not more than that. And you gave me the answer yourself. Okay, 255, right? So now a simple question for you. How many IPs could be there in total from the first IP till the last IP? Can anyone give me a rough answer of how we could calculate that? Himanshu, Kiran, Vishwanath, Suraya.
Can you repeat the questions?
Oh, yeah, simple. Again, I'm asking how many IPs could we have in total from the first IP till the last IP? So we know the first IP is 0, 0, 0, 0, and the last IP is 255, 255, 255, 255. So my question is, how many IPs could be there in total from the first IP till the last IP? Any answers?
2 IPs.
Sorry, how many? Kiran? 2 IPs? No, not really. If you notice, this is the first IP, this is the last IP. And again, there were other IPs as well, if you remember. In our previous slides, if we go back, you could see
196.
how 196. So if you notice, there were these IPs 192, 168, and that is also one IP. Okay, we have again, we can how many IPs would we have in total like that? So if you notice over here, each octet can be of two possible values, either 0 or a 1. And you have 32 bits like that. Okay. You can either put a 0 or a 1 in each bit. So here there's two possibilities. Here there's two possibilities. Here there's two possibilities. Here there's two possibilities. Like that, you have 32 possibilities. I mean, for each bit, you have two possibilities where you have 32 bits. So that in order to calculate the total number of IPs, you would get it with a simple number 2 to the power 32 because you have two possibilities into 32, 2 to the power 32. And that would give you a number of 4.3 billion IP addresses approximately, right, Kiran? Not two. This is the first IP, this is the last IP. But in between, there are 4.3 billion IPs more, right? If you still don't get that, let me show this with a very simple example. Okay, let me try to show you the list of all IPs, all the 4.3 billion IPs. So to calculate the range of IPs, guys, there's two simple rules again. So again, rule number one, if I write this out in a notepad file, just a second. Let me open up a notepad file first. Yeah. So let's assume this is the first IP here, 0, 0, 0, 0. Okay. Now, if you want to get the next IP, rule number one is you always increment the rightmost value first. Okay. So after 0, 0, 0, 0, next IP would be 0, 0, 0, 1. Next 0, 0, 0, 2. Next 0, 0, 0, 3. Each of these is an individual IP, right? 0, 0, 0, 4. 0, 0, 0, 5, 0, 0, 0, 6. This goes on all the way up to the value 0, 0, 0, 254. And then you would have something like 0, 0, 0, 255. Now, after this, can we have a value like 0, 0, 0, 256? Is this possible, guys? 0, 0, 0, 256. Is this possible? Can an
No.
octet? Yeah, it definitely is not possible, right? So once you reach the maximum octet there in the rightmost value, then what happens is that octet resets back to 0 and the next octet increases by 1. So after 0, 0, 0, 255, you have 0, 0, 1, 0. Okay, so the 255 cycle back to 0 and this next 0 changed to 1. Now after 1, 0, don't directly jump to 0, 0, 2, 0. That's wrong. Remember rule number one, always increment the rightmost bit. Okay, always start incrementing from the rightmost octet. So after 0010, you have 11, then 0012, then 0013, 0014, 0015. You can see this is the same pattern repeating. Whatever repeated from 00 to 0255, same thing repeats from 10 all the way up to 001255. Then you have 0020, which goes up to 002255. Then you have 0030, which goes up to 003255. Then 0040 goes up to 004255. I'm skipping a lot of IPs in between, guys, but I hope you're getting the sequence. After 004255, you have 0050, which goes up to 005255. Okay, like that, the cycle keeps on repeating, and somewhere you'll have 002550 to 00255255. Now both these octets are filled. What happens after that? Next IP 0100. Okay, so same thing. Whatever cycle repeated here from 000 to 0255 same whole cycle repeats again from 0100 to 01255255. Okay, so same thing. After 01, you would have again 01. So again 00, 01, 02, 03 goes up to 0255. Okay, then 0110, 11, 12, 13 goes up to 1255. Same cycle, whatever is repeating here, 00 to 0255, 10 to 1255. Same cycle repeats here as well, 00 to 0255, 10 to 1255. Okay, 11255. Like that, it goes up to 1255255. Then 0200 to 02255255. 0300 to 03255255. 0400 to 04255255. Like that, the cycle keeps on repeating. And somewhere you'll have 025500 to 0255255255. Once now it reaches the maximum values here, the 0 now changes to 1. So whatever repeated from here, from the first IP till here, same cycle now repeats again from 1000 to 1255255. Then 2000 to 2255255255. Then 3000 to 3255255255. Like that, it keeps on repeating till the last octet as well. 255000 to 255 Here's the first IP, and here's the last IP. So if you keep on counting each and every single IP like that, in total, you would go up to the value of 4.3 billion IP addresses in total. So that is how you get the total number of IPs. Another simple way of calculation is each octet has two possibilities, and you have 32 octets. So 2 to the power 32 would give you the same value, 4.3 billion IP addresses. Is that clear now, guys? For people who could not understand how we got that number 4.3 billion, does it make sense now? Vishwanath, Kiran, Suraya. Right. Kiran, any questions for you?
Yes.
I hope this makes sense.
Yes.
Right. So again, definitely a few complex topics, guys, because this might seem completely new to you. But again, if you just practice this out, if you go through the document one more time, it might make even more sense. And please do some research as well. Try to go to the internet today if time permits. Try to do some research on what IPv4 addresses are. What is the sequence? How do you convert a binary number to a decimal number? Try refreshing it about it. Okay. So, and that would again make things foundationally stronger. Okay. So again, nothing further for our class, guys. Let's stop here itself because it's too complex already. We'll break it down in smaller chunks and then consume this. Okay. So again, we are stopping over here today in understanding what the sequence of IPs is. In the next class, we'll talk about the classification of IPs. Okay, what are the categories in them? So there's something called classes again, class A, B, C, D, and again, public and private IPs. So we'll talk about all of those classifications in the next session. Okay. So again, it's going to get slightly more complex in the next session, guys, but don't worry. With practice, this gets a lot easier. Okay. For now, this is a brief introduction on what IPv4 addresses are. Okay. So all we have learned today is what are the properties of an IPv4 address? How does it look like? How do you convert any number from binary to decimal? And from that conversion, we got the range of IPs. What's the first IP and what's the last IP? And from that range itself, we figured out how many IPs are there. And we got the number as 4.3 billion IPs. Now, these 4.3 billion IPs are not sufficient in today's world. Okay. So that is why they've classified them in different categories. Okay. So we'll talk about those categories in the next session. Okay. So please do join the session tomorrow as well, guys. It's going to get much more interesting where we learn about the different categories of IPs. Okay. Public IPs, private IPs, and the classes in them. Okay. So same time tomorrow, please join at the same time. And again, we'll go or we will progress much further ahead. Okay. Before we exit, any questions? Vishwanath, Kiran, Suraya, is there anything that you want me to explain again? Please do not hesitate, guys. Even if you ask me a million more times, I will still explain it every single time in a much more simpler way so that these foundational concepts get stuck in your head. Okay, so these are very important in any domain in IT field. So again, it's better to get these imbibed in your mind. Okay, so any questions, Kiran, Vishwanath? No, nothing as such, Vishwanath. Again, only for these IP address concepts, we require some math. Other than that, in our upcoming sessions, we'll not be using mathematics anywhere. Okay, just to understand these concepts. Only in our first class, we had some basic math requirement. In the upcoming sessions, we'll not be using math anymore. Okay. So again, when you go to the fundamentals, math is required in computer science. But again, as we progress, there is no more requirement of mathematics. Any other questions, guys? Okay, assuming no questions, guys, let's exit the session here today and let's connect back tomorrow at the same time. And please, as mentioned, guys, please register at the earliest. We only have 2 more demo sessions, which is tomorrow and day after tomorrow. And after that, the link is going to change. Okay, so only the paid link will be provided to people who have registered. Okay, so yeah, bye bye. Good day. See you tomorrow at the same time.